In the stillness of a July night in 2025, a faint moving speck appeared in the southern sky above Chile. The Atlas telescope registered it first, just another dim object, buried deep in the background of the cosmos. But when astronomers began to calculate its orbit, the numbers refused to make sense. This object wasn't circling the sun like every asteroid, comet, or planet we know. It was cutting through the solar system, a path so steep and swift that it could only have come from interstellar space. They named it 3I Atlas, the third interstellar object ever detected by humankind. Before it came Oumuamua in 2017, a needle-shaped mystery that left scientists arguing for years. Then 2I Borisov in 2019, a comet from another star. And now, 6 years later, a new messenger had arrived, gliding quietly across the void between worlds. At first, 3I Atlas seemed harmless, almost ordinary, a frozen mass of rock and ice reflecting the distant sunlight. But its behavior refused to fit the pattern. Its velocity was extraordinary, fast enough to escape the sun's gravity forever. Its orbit was tilted yet eerily aligned with the plane of the planets, as if it had deliberately chosen a route through familiar territory. Ground-based observatories joined in, their lenses tracking the faint wanderer as it approached the inner solar system. The Hubble Space Telescope prepared its instruments. Researchers from Harvard to the European Space Agency compared notes, searching for signs of rotation, outgassing, or an invisible tail. Each new calculation only deepened the mystery. Estimates suggested a nucleus, somewhere between 5 and 40 kilometers wide. Small by cosmic standards, but immense for an interstellar fragment. And then came the most startling revelation. 3I Atlas might be older than our solar system itself. Its atoms were forged long before the sun was born, perhaps in the cradle of a distant star that died billions of years ago. For scientists, it was a once-in-a-lifetime event, a chance to study raw material from another world, to touch, through light and mathematics, the history of another sky. But for many who watched the data unfold, the feeling was something quieter, almost spiritual. Some called it coincidence, others choreography. A traveler older than Earth itself, passing through the space we call home, as if to remind us that the story of the universe is far larger than the orbit of our own sun. When the Hubble Space Telescope turned its gaze toward 3I Atlas on July 21, 2025, scientists expected to see something familiar. A comet blazing with dust and gas, a long tail stretching away from the sun. But when the first image appeared on the screen, it wasn't what anyone imagined. Instead of a brilliant streak, Hubble revealed a soft, spherical glow. At the center was a hidden core, surrounded by a faint, luminous haze that seemed almost perfectly round. There was no elegant tail flowing into space, no obvious jets of dust, only a quiet cloud of light suspended in the dark. At first, the researchers assumed it was a technical issue. Maybe the exposure time had been too short. Maybe the angle of observation had hidden the tail from view. But the data didn't agree. When the image was analyzed, one detail stood out. The glow seemed to stretch slightly toward the sun, not away from it. That was impossible. Every known comet releases material that is pushed outward by solar radiation and the solar wind, forming a tail that always points away from the sun. Yet 3I Atlas was different. Its light was extended in the wrong direction. Among those studying the image was Harvard astrophysicist Ivy Loeb. He measured the brightness across each pixel, tracing the symmetry of the halo. His conclusion was careful but unsettling. Perhaps, he wrote, the light we see isn't just sunlight reflected from dust. Perhaps some of it is being generated by the object itself. No one could confirm such a claim. The idea of a self-luminous object crossing our solar system bordered on the extraordinary. But the observation demanded explanation. If not sunlight, What was powering the glow? Could sublimating gases create a forward-facing plume? Could the angle of rotation make it appear that way? Theories multiplied, but none fit neatly. Some dismissed the observation as a trick of geometry, a coincidence of angle and exposure. Others began to wonder whether 3I Atlas might not be entirely natural. Hubble's image became a puzzle frozen in light. The comet without a tail, glowing toward the sun, was unlike anything seen before. Somewhere within that faint blur, the truth waited, 30 million kilometers closer with every passing day. By early October, 3I Atlas had drifted deep into the inner solar system, gliding past Mars on its long escape toward the stars. For the first time, humanity had a chance to see an interstellar object from relatively close range. 2 European spacecraft were in perfect position, ExoMars Trace Gas Orbiter and Mars Express. Both turned their cameras toward the faint visitor. On October 3, 2025, 3I Atlas passed within about 30 million kilometers of Mars. To a human eye, that distance would still seem infinite, but for science, it was the closest view yet of an object born beyond our sun. The orbiter's cameras, built to photograph the bright surface of Mars below, were now pushed to their limits, capturing something 10,000 times dimmer than their usual targets. The CASIS camera aboard ExoMars took a sequence of 5-second exposures. In those frames, scientists could see a single fuzzy white dot sliding slowly across the blackness. That blur was the core of 3I Atlas and the cloud of gas and dust surrounding it. The camera couldn't distinguish the nucleus itself at that distance. Resolving a 5-kilometer-wide object would be like spotting a mobile phone lying on the moon from Earth, but it caught the faint coma glowing around it, a halo several thousand kilometers across. ESA's principal investigator, Nick Thomas, described the attempt as a challenging observation for an instrument not designed for darkness. Yet the result was clear. The coma shimmered softly, bright against the noise of space, proof that 3I Atlas was awake, releasing gases as sunlight touched its surface. Still, something was missing. The iconic comet tail, the long stream of particles pushed outward by the solar wind, was nowhere to be seen. The data showed that its brightness faded rapidly away from the nucleus, dissolving into the background before any tail could form. The mystery that began with Hubble deepened. This comet behaved like no other. Meanwhile, Mars Express recorded its own images, though its 0.5-second exposure limit captured no visible trace of the comet. ESA scientists are now stacking multiple frames together, hoping that the combined light will reveal a hint of 3I Atlas hidden in the noise. Across millions of kilometers, Mars became a stage for the second act of this interstellar story. 2 robotic witnesses watching a visitor older than the solar system itself. In those grainy pixels, humanity's curiosity stretched once again toward the unknown. Comets are supposed to breathe. As they approach the sun, frozen gases awaken, dust erupts, and a long, radiant tail unfolds behind them, the unmistakable signature of a traveler from the cold. But 3I Atlas refused to follow that script. When scientists analyzed the Mars orbiter images, they found no flowing arc of vapor or light. The coma was there, a faint shroud thousands of kilometers wide, but beyond it, nothing, no tail, no stream, just silence. At first, researchers thought the angle was deceiving. Perhaps the tail was hidden behind the nucleus, invisible from Mars's perspective. But the numbers didn't fit. Even when they simulated every possible orientation, the result was the same. The dust brightness dropped too sharply. The tail simply wasn't there. To the human eye, this absence might seem trivial, a missing streak of light in a photograph. But to astronomers it was a profound anomaly. The tail isn't just decoration, it's physics. It tells how a comet lives, how it reacts to the sun, how it dies. For 3I Atlas to glow without one meant that something was fundamentally different in its chemistry, its structure, or its story. ESA's scientists suggested that the comet might be coated in dark, carbon-rich material that resists sublimation, sealing its icy core beneath a shell of ancient rock. Others, like Avi Loeb, proposed another possibility, that the forward-facing glow seen by Hubble and now Mars orbiters might not be dust at all, but a plume, a jet of gas directed sunward by the comet's own spin. A strange thought, but one that matched the data. If that were true, then 3I Atlas wasn't merely surviving the sun's heat. It was fighting it, releasing gas in the opposite direction of the solar wind. A quiet defiance written in light. For weeks, observatories across Earth tried to confirm the anomaly. Ground telescopes strained to capture its faint shimmer through the glare of daylight. No clear image came. All that remained was that lonely sphere of haze, suspended between Mars and the sun, reflecting a mystery back at those who watched. In the dark vacuum where every other comet sheds its identity, this one held its silence. A wanderer from another star, still refusing to play by our rules. After the first images from Mars, a strange quiet fell over the astronomy community. The object that had defied every expectation was now too faint for most ground-based telescopes, and the next set of eyes that could study it, NASA's Mars Reconnaissance Orbiter, had just gone silent. At the worst possible moment, the United States government entered a shutdown. Budgets froze, communication lines stalled, and entire data pipelines from Mars were suddenly locked behind bureaucracy. HiRISE, the most powerful camera orbiting the red planet, had already taken its images of 3I Atlas, but no one on Earth could access them. For scientists, it was torture knowing that the answers might already exist, trapped inside a machine millions of kilometers away. Avi Loeb, speaking in an interview, summed it up with a dry smile. "The delay," he said, "isn't a sign of extraterrestrial intelligence. It's a sign of terrestrial stupidity." Still, the waiting continued. At Harvard, Loeb's team compared the brightness levels between the Hubble and ExoMars data, calculating that the coma extended nearly 700 kilometers, far smaller than what Hubble saw months earlier. No new material seemed to be escaping. No sudden burst of activity. 3I Atlas was holding steady, fading only as sunlight scattered across its distant haze. Meanwhile, ESA scientists worked to squeeze every photon from their limited images. Mars Express engineers combined multiple exposures, stacking them in search of a ghostly signal. Spectrometers aboard both orbiters Nomad, Omega, and SPECAM searched for chemical fingerprints in the faint glow, hoping to detect water, carbon dioxide, or traces of complex molecules. But the data was thin, almost silent. It was like trying to listen for a whisper during a storm. Days passed. Weeks. The story slipped from headlines, buried beneath newer news cycles. But for those still watching, the mystery only deepened. The longer the silence lasted, the louder the question became. What exactly was 3I Atlas? High above Mars, the answers remained locked inside orbiters drifting through the thin red sky. Below, on Earth, hundreds of scientists stared at their screens, waiting for the next transmission, waiting for light from another world to finally speak. Far above the red surface of Mars, a single spacecraft drifted in silence. The Mars Reconnaissance Orbiter, home to the HiRISE camera, was humanity's sharpest eye beyond Earth. With a mirror half a meter wide, HiRISE could photograph the shadow of a rover, the outline of a rock, even the ripple of sand dunes. Now, that same instrument was pointed toward a faint speck, 30 million kilometers away, 3I Atlas. For weeks, the world had waited. ExoMars had shown a blurry glow. Hubble had revealed a strange forward-facing haze. But high-rise, with its unmatched clarity, might finally reveal the truth. The size of the nucleus, the structure of the coma, and whether the interstellar traveler carried a hidden signature of something never seen before. The calculations were staggering. Each pixel of the high-rise image covered about 30 kilometers of space at that distance. A single bright point could define the upper limit of the nucleus's diameter. Astronomers hoped the camera might resolve the comet's brightest region, capturing the edge between matter and mystery. Then silence. NASA's communication lines remained frozen under the government shutdown. The images existed, stored somewhere inside the orbiter's memory, but no one could see them. The most detailed photograph ever taken of an interstellar visitor was stranded in orbit, like a message in a bottle. Avi Loeb called it a moment of cosmic irony. He had calculated that the ExoMars image showed a glow about 680 kilometers wide, nearly 10 times smaller than what Hubble saw months earlier, implying that the orbiter captured only the inner core of the light, missing the faint extended halo. If high-rise could pierce deeper, it might reveal the boundaries of that fading glow, or perhaps prove that the brightness came from something more structured. But until the data arrived, everything was speculation. The world's finest telescopes had opened their eyes to the universe, and now the universe was forcing them to wait. Somewhere between Mars and the stars, 3I Atlas continued its silent path, its reflection shrinking day by day, and on Earth, 1,000 questions orbited around a single pixel of light, a pixel that might change how we see our place in the cosmos. Every comet tells a story of origin. Most were born with the sun itself, fragments of the same swirling cloud that shaped the planets. But 3I Atlas was different. Its chemical fingerprint, its speed, its unbound orbit, everything about it whispered of another birthplace, somewhere far beyond our own star, in a system that no longer exists. This object had once circled another sun. Astronomers studying its trajectory realized something astonishing. If their models were correct, 3I Atlas could be 3 billion years older than the solar system. That means it formed long before Earth existed, when the Milky Way was still young and restless. The materials inside it, carbon, water, frozen gas, were among the oldest untouched relics in the galaxy. To glimpse it, even briefly, was to look back across cosmic time. ESA's data hinted that 3I Atlas had traveled through interstellar space for eons, bombarded by radiation, stripped of its outer layers, its surface hardened into black rock. Its ice may have survived only in deep pockets within, sealed away since before our sun ignited. The journey would have changed it, scarred it, frozen it into silence. And yet, here it was still holding together, after billions of years adrift between the stars. To scientists, that resilience was humbling. It meant that in the vast emptiness of the galaxy, a fragment from another world could endure long enough to cross light years and pass through our own sky. Every observation, every pixel, was a message from a time when the universe was half its current age. Avi Loeb described it as a survivor of cosmic history. To him, 3I Atlas was not just a comet, but a messenger, a piece of another civilization of worlds, one that may have risen and fallen before ours even began. Perhaps somewhere, billions of years ago, another species once looked up at its sky and saw this same object leaving home. Now, after an unimaginable voyage, it had come here, not to stay, but to pass quietly, indifferently through the system of another young star. For a few fleeting months, its reflection touched our telescopes, our instruments, our imaginations. And then, just as it had appeared, it began to fade into darkness once more. By late October, 3I Atlas was already drifting away from Mars, its glow fading into the emptiness. Telescopes across Earth still searched for it, but each night the light grew weaker, dissolving into the background of stars. Its time in our skies was almost over. In a few short months, it would slip beyond the reach of any human eye, another brief echo in the endless night. But the encounter had changed something. It reminded scientists that the solar system is not a closed world, but a crossroads. Other stars send us their fragments, travelers, carrying the chemistry and history of alien suns. Each one is a messenger, a relic from the galaxy's ancient past, whispering that the story of life and matter extends far beyond our sun. Next year, the JUICE spacecraft, orbiting near Jupiter, will turn its instruments toward the same region of space where 3I Atlas now drifts. It will search for traces of its tail, for the last glimmers of dust that might still reflect the dying sunlight. And in the coming years, ESA is preparing for something even more ambitious, the Comet interceptor mission. It will wait in a stable orbit, a sentinel suspended in space, ready to launch toward the next unknown object that enters our solar system. Perhaps it will be a pristine comet from the Oort cloud. Perhaps, against all odds, another interstellar traveler like 3I Atlas. For scientists like Avi Loeb, the goal is clear: to be ready when the next visitor arrives. Each encounter is a chance to glimpse the broader galaxy, to test whether our understanding of natural still holds. If 3I Atlas taught us anything, it is that the universe still keeps secrets even from those who watch it most closely. In the quiet wake of its passing, the world's telescopes continue to scan the heavens, each one waiting for the next faint speck to move against the background of stars. And somewhere out there, between the constellations, another traveler may already be on its way. A grain of time, a shard of memory, crossing the cold dark between suns, coming once more to remind us how small we are, and how endlessly connected this universe will always be.